Hi, my name is Lisa Kirby, and I am here today to present our work, Weighing the Evidence on Relationship Types in Microservice Extraction. This is a joint work with Eveline Borstra, Zachary Anderson, and Professor Julia Rubin from the University of British Columbia in Vancouver, Canada. Let's dive in. The microservice-based architecture is an approach wherein a monolithic application is split up into a system of services that are deployed and developed independently. These services communicate with each other over the network through lightweight interfaces like REST. This approach allows systems to be built with multilingual tech stacks and enables developers to independently deploy and scale out different parts of the system. This table presents automated microservice extraction techniques that identify how a monolith can best be divided into microservices. We won't go into the table in detail, but the main takeaways are that at a high level, these techniques will take in information about a monolithic application, extract a graph-based representation of it, and then cluster the elements of this graph into microservice recommendations. The most significant difference between the techniques is in how they construct relationships or edges between the elements of the graph. Different techniques use different types of relationships because each type supports its own goal for microservice extraction. Edges are constructed using one or a combination of structural, semantic, and/or evolutionary relationships. The goal of using structural relationships is to minimize inter-service calls and performance overhead between microservice candidates. These relationships include inheritance, method calls, and data dependencies between elements. The goal of using semantic relationships is to capture business domains. To do this, tools rely on techniques from the field of natural language processing. Some consider similarity between names of the main elements, for example, class names, and some consider similarity between all terms of elements, like variable names, method names, and comments. The goal of using evolutionary relationships is to capture components that can be developed and deployed independently. These relationships can include the similarity between the commit histories of two elements or the similarity between the developers who have contributed to each element. With these relationships in mind, we aimed to investigate two research questions. One, what is the usefulness and applicability of these relationship types during the extraction process? And two, what features would benefit automated extraction tools that use relationships? To answer our research questions, we took an exploratory approach, talking to experienced practitioners. Here is a table that summarizes their backgrounds. We conducted this study with software developers and architecture consultants from 8 companies across 6 countries. All have experience with at least one large and complex migration to microservices. To answer RQ1, we performed semi-structured interviews, during which we described the relationship types and asked practitioners the following questions. Which relationships do you find useful for microservice extraction and why? What is the relative importance of these relationships? Are there any additional relationship types you find useful? And what characteristics of an application or organization can change how you use relationships? Our results showed that while each relationship type has its value and intended use, there are a number of scenarios in which each type needs to be reconsidered and customized. Older and larger code bases may deter practitioners away from using structural and semantic relationships, as these code bases often have many dependencies on elements that cross-cut concerns, and class or variable names that no longer have clear meanings. Smaller teams can deter practitioners away from using evolutionary relationships, as developers from smaller teams often work on many different parts of the code simultaneously. In contrast, larger teams can deter practitioners away from using semantic relationships, as to paraphrase one of our practitioners, more developers leads to more differences in how things are named. Semantic relationships can also lose value in teams wherein the main spoken language differs across developers, since there's often ambiguity in how things are communicated and named. Lack of access to version control history or execution trace data can also deter practitioners away from using evolutionary or structural relationships, respectively. Additional scenarios and details can be found in our paper. To answer RQ2, how can tool support be improved? We developed a prototype microservice extraction tool that can use structural, semantic, and/or evolutionary relationships. It also allows users to visualize the different relationships, to filter out weaker edges, and to enter in relationship weightings that control the impact each relationship type has on the clustering result. We then conducted a Think Aloud study with practitioners, during which we introduced them to a basic Java app and asked them to use our prototype to extract microservices from this app. We asked them to share their thoughts about what worked and, more importantly, what features were missing from this generic prototype. We found that there are several features the practitioners wanted to see in extraction tools. They'd like extraction tools to support visualizing and investigating different relationship types. They'd also like tools to allow them to customize elements and relationship weightings. For example, some practitioners wanted to increase the granularity level of the elements in our prototype from class level to package level. Practitioners also wanted tools to support what-if analyses of extractions, wherein users can iteratively customize relationship weightings and clustering parameters until they are satisfied with the results. They'd also like to interact with tools by fixing decomposition decisions, for example, by manually grouping elements together, and then by having the clustering respect this manual grouping. More feature suggestions are available in our paper, and we are excited to collaborate with the research community to make them a reality. To summarize, in this talk, I gave an overview of microservice extraction techniques and summarized the relationship types they use. I then presented the results of our study on the usefulness and applicability of relationship types and summarized multiple features practitioners expect from extraction tools. Please feel free to reach out to me and the rest of the team if you have any questions.
Okay, open this area. We should open this area. Okay.
Hi.
Hi. So I'm wondering that the live question and answer session started or not? We already started. I don't know how can we realize that.
I think we're live right now.
Oh, great. So do you have any question for Lisa? So please post your question. So maybe it takes okay. Sorry. So let me introduce my thank you Pavyon. Let me introduce myself. I'm Jung Choi, a session chair of this Understanding System 1, and I'm an assistant professor of Kyoto Institute of Technology in Japan. And please, I know that you already saw the interesting video from Lisa. So if you have a question, please post your question in cloud. And I have one question for you. So I'm very surprised with your research answer to your research question 1, which indicate the applicability and usability of different relationship type is highly depends on the application scenario. Were you expecting this answer when you prepared the research?
Right. So our answer implied that,
Oops. So just a connection problem or oops.